Okay, we're going to be now finally moving into the new stuff. Introduction to Limits. We're working off page 499, and we're going to do problems 13 and 15, which refer to this picture, and then we're going to do problem number 23, which refers to this picture. This first one here is the graph of the function f of x. Very weird graph. We see obviously that's not one of our standard graphs that we dealt with in the past, but problems or graphs like this help us understand the idea of the limit. So let's start here with number 13a. Part A says for us to find the limit as x approaches 0, with a little negative sign there, of f of x. So what we want to do here is we want to, first of all, find where is x 0. So x is 0 is here, and we're going to just look like at a vertical line here and imagine that we are approaching this vertical line on the function from the left side. So the negative means from the left side. So we're coming in from this side, trying to get to this vertical line, but we're walking along the function. So if we're walking along this function, the question is, how high are you? Okay, so you can see that as you move from left to right here, your height doesn't change. And it looks like your height is always 2, right? So from the left, approaching x is 0, our function's height is approaching 2. So it just stays the same the whole time. There's really nothing interesting happening there. Now, for part B, they want to know what's the limit as x approaches 0 with the plus sign there on this function, which means we're going to be, again, approaching 0, but this time from the right side. So, you know, you're doing all this weird stuff over here, but as we get close, we're walking along here, as we get closer and closer to 0 for x, our height here, it goes up to 2, and then it just holds steady at 2 as we get closer to 0. So we have the same answer. So from the left and from the right, as we approach this vertical line x equals 0, we're going to maintain a height of 2 the whole time. All right, let's look at part C. Part C says, what is the limit as x approaches 0 of this function? And notice that they don't put plus or minus here. So since they don't put plus or minus, here's what you need to do. You need to look at the limit from the left and from the right, which we already did, and we need to see if these two numbers go to the same place. If they do, then the answer is that number, which in this case they do. Both go to 2, so our answer is 2. If these were not the same numbers, then our answer would be that this limit does not exist. Okay, part D asks, what's f of 0? So we're now looking at this more from the perspective of like an algebra class. If you plug 0 into this function, is there a dot somewhere? So if we plug in 0, where's the function? It's right there. You can see since it's a solid line, that really means there's a dot there. And so the value of the function there is actually 2. So it looks like there's not a whole lot of interesting stuff happening at 0. As we come in from the left and from the right, it's headed towards 2. And actually, at 0 itself, it's 2. So it's a nice, well-behaved function at x equals 0. Now let's look at the difference between that and problem 15. On problem 15, we're using the same graph. And the first one, we're going to be approaching, all that's going to change is that this is going to be 2 from the left, 2 from the right, 2 here, and 2 in here. And what we need to do is figure out what these answers are. Okay, so now we're going to approach 2 from the left. So here's 2, x is 2. And as we come in from the left, we're walking along, and then we start dipping down. And notice our y values are starting to get smaller, and they're approaching a y value of 1. So it looks like I'm coming into 1 here. Again, we don't care about what's happening exactly at 2, just from the left. So you can see we're coming in, and our height is approaching the height of 1. We never get there, but it's approaching 1. So from the left, it is 1. Now as we get onto the function, we approach x equals 2 again, but this time from the right side, we're walking along here, and notice our heights are up here, they're past 3, now they're underneath 3, and it looks like we're getting closer and closer to a height of 2 from the right. So this is approaching 2. Now we want to know what's the limit as x approaches 2 without the plus or minus. That means you have to look at both of these and see if these numbers match. They don't. So this limit does not exist. Does not exist. DNE does not exist. Then this is back to the more algebra perspective. What is happening exactly at 2? Not from the left, not from the right, at 2. So at 2, notice that this is an open circle, which means that's not the function. It's not defined there. But that's a solid dot. Therefore, our function's value at 2 is actually that height, which is 2. All right, I hope that makes sense. Let's move on to number 23. For number 23, we are going to not need this graph. We're going to use that graph over there. And so for 23, we are being asked, first for part A, to find the limit as x approaches 3 from the left of this function g. For part B, I'm going to guess we're going to approach 3 from the right of this function g. And then C, it wants to know what's the limit as x approaches 3 of the function, which means you have to check both left and right. And then for part D, it just wants to know what's g of 3. Same sort of ideas here. So let's go to 3 out here. Here's 3. As we approach 3 from the left, we're up here, up at a height of 2. Then we start dropping down, and our height looks like it's getting closer and closer to 1. We're never going to get there, but it's getting closer to 1. So this limit is 1. From the right-hand side over here, this is this question. I forgot. Oh, oops. This one up here is 1. We're coming in from the left. From the right-hand side, we're walking along. We're down here, and then our values start coming up, and it looks like we're getting closer and closer to 1 again. So our limit is 1. Again, we don't care that at 3, we don't care that there's a hole. We only care from the left and from the right. Okay, that's what these limits are asking. From the left and from the right, what's happening. So what is the limit without plus or minus? Well, check these. Are they both the same? Yes, they are. They're 1. So from either side, our function's height is approaching a y coordinate of 1. Now, what is the actual value of the function at 3? So at 3, if we plug in, where are we? Oh, we're up here at 3. We're not at 1, we're at 3. So the answer, g of 3, is 3. Okay, let me see what this is. Moving along, moving along. Number 29. Number 29. These, we're just asked to evaluate these limits. Limit as x approaches 3 of 4x, 4 times x. So when we do limits, what we first try and do is just what we call the substitution principle. You're going to let x get close to 3. That means you're going to try just substituting 3 in here and making sure you don't get anything crazy. So 4 times 3, that would just be 12. And if it comes out to not be anything crazy like division by 0 or 0 over 0 or something like that, then your answer is just that result, 12. And that's it. Don't make it more complicated than that. Same with this next one, 31. Limit x approaches 4 of the quantity x plus 5. So I'm just going to try this direct substitution. Oh, it was negative 4. Sorry. Try direct substitution in here. What would happen if I replace that with negative 4? Negative 4 plus 5, that's 1. That's not a problem. No division by 0, no weird expression. We're happy. We keep going. 33. Limit x approaches 2 of x times x minus 4. All right, try direct substitution. We get 2 times 2 minus 4. So this is just 2 times 2 minus 4 is negative 2. 2 times negative 2 is negative 4. Again, we didn't run into anything bad. So all three of these problems, it's just like, it's almost like we're just telling you to plug these numbers in here. That's essentially what's happening. Things don't get interesting until later, all right? We're not at later yet. But let's do 35. So for 35, limit x approaches negative 3, and we have x over x plus 5. Now we have the potential here for a problem because we have division. We could have 0 down there, but let's see. X is approaching negative 3. So what would happen if I directly substituted negative 3 in here? I'd have negative 3 over negative 3 plus 5. That would give me negative 3 over 2. And that's not a problem. That's not division by 0. It's not some crazy looking thing like 0 divided by 0 or any square roots of negative numbers. We're all good. Okay, so that's it. That's it. Again, don't make this more complicated than it has to be. Let's try the next one. 37. Limit x approaches 1 of the square root of 5x plus 4. Try direct substitution. If I replace that with 1, I get square root of 5 times 1 is 5. 5 plus 4 is 9. Square root of 9 is 3. We're done. Nothing bad happened. Things are really nice right now. We got lucky. It'll get bad later. All right, moving on. Number 51. Okay, now things are going to get a little weird. All right, so they give us a function f of x equals, and then they give us this thing called a piecewise function. It's 1 minus x squared, and then 1 plus x squared. But it's only 1 minus x squared if x is less than or equal to 0, and 1 plus x squared if x is greater than 0. Greater than 0. And they ask us for some limits. Well, I think we need to get some idea of what this thing looks like graphically. Let's go for it. All right, we all need to know what x squared looks like. X squared looks like a parabola that opens up. Right? It would go like this, whoosh, whoosh, like that. Negative x squared would be a parabola that opens down. It would go right through the origin like this. Okay? Now, 1 minus x squared is the same as negative x squared plus 1. So that's the same as this. So what that means is if you took negative x squared, which is that parabola that opens down, and then shift the whole thing up 1, it would look like this. So here's 1. It would look like this parabola right here. Okay, that would be this one right there. However, I think I'm going to do this in a different color. Let me erase this. Here's 1. Oh my gosh, my phone keeps going off. Okay, so it would look like this right here. But I only want to draw it for x less than or equal to 0. So here's x, here's positive, here's negative. I only want to draw that parabola to the left of 0 and including 0. So I know at 0 I have that dot, and then my parabola opens like this. Okay, so that's what the graph looks like so far. Then I have this function, 1 plus x squared. Well, x squared by itself is a parabola that opens up. Adding 1 to it moves it up 1. So I'm going to have that parabola like this, and I move it up 1. So it would look, instead of like this, it's only going to be the right side of it because I'm only drawing it if x is bigger than 0. And notice that that would mean I have an open hole for this part, this red part. Now the hole is being filled in because of the blue part, we're actually defined at 0. So you take the left side of the blue graph and the right side of the red graph, and you put them together and you get this new graph. And now we can go and answer some questions. First one, part A, is what's the limit as x approaches 0 from the left, from the right, and 0? Okay, so here are the 4 things they want. What's the limit as x approaches 0 from the left? Then they want to know what's the limit as x approaches 0 from the right. Then they want to know what's the limit as x approaches 0 from both sides. And then finally they want to know what is f of 0. Okay, so what's the limit as we approach 0 from the left? So here's 0, x is 0. As we come in from the left, our blue graph is approaching a y value of 1. So it's approaching 1. As we approach 0 from the right, we're on the red part, we're coming into 0. And again, notice that our y coordinates are approaching a y value of 1. So this is also 1. Since these two match, that means this is equal to 1. And now what is the function's value at 0? Well, if you just plug 0 in, you plug it into the top one, because this says use this one if x is less than or equal to 0. So I plug 0 in here, I get 1, which was that solid dot. So the answer is 1. So we got 1 for all of those. So from the left and from the right, it approaches 1. And then at 0, it's actually 1. So not a whole lot of interesting stuff happening with that function. I'm sure the next one will be a little bit different. Okay, number 53. X squared if x is less than 1, and 2x if x is greater than 1. Notice that neither one of these have equal, right? And they want to know limit x approaches 1 from the left of this function, limit x approaches 1 from the right of this function, limit x approaches 1 of this function, and then they also want to know what is f of 1. All right, so I'm going to draw a picture to help us. And let's start with this one. X squared, I'm only going to draw this to the left of 1. So here's 1 on my graph. To the left of 1 is where I'm drawing that. Now x squared, again, is that parabola that opens up. So we know that it should look like this and come this way like that. But I'm going to stop it right there and bring the rest of it up. Now when I get to 1, it's an open circle because there's no equal sign here. So that's what it looks like, the blue part. The red part, 2x, we know that 2x is a line. You could actually look at this as being 2x plus 0. Then it looks like mx plus b. So our y-intercept would be 0. And then we go, slope is 2. So 2 is the same as 2 over 1. So that would mean up 2, 1, 2 over 1. So up 2 over 1, and I would put a dot here. And then I would draw a line. However, I only want to draw the line to the right of 1. So I don't want to draw this. I only want to start picking it up from here and drawing that line. So to the right of 1, I'm drawing the line. And also notice that here is an open circle. It's an open circle because there's no equal sign here. So that's our graph. Now you had to kind of know, I kind of jumped over this a little bit. You had to know that this value was 1 here when you drew the parabola, because in x squared, if you plug in 1, you would have gotten 1, right? So if you would have plugged in 1, you would have gotten 1, but we're not allowed to. But it gives you an idea of where it would have been, right? So you can draw your circle here. So now let's ask what's happening as we approach 1 from the left. So here's 1. From the left, our y value is headed towards 1. From the right, we're on the red one, and that one, remember, we went up 2 and over 1, so that y value is approaching 2. And that means that it's not the same from the left and the right, so this limit does not exist automatically because they don't match. And then the final question is, what is f of 1? And f of 1 means if you plugged 1 in this function, where is it? And notice that we didn't have any dots, which means that the function is undefined at 1. So we put undefined. We do not put does not exist. We only use does not exist for limits. When functions fail to have any points on them at a certain point, right? If we plug in and we don't get anything, like we have here, then we say it's undefined. And that's it for that one. Okay, the next one is going to be a little bit of work. I hate to do this, but I'm going to step out for just a minute. And I don't like to stop the video because then I have to make more than one video. So I'm going to just mute it and be back. All right? Sorry, it's going to be a few minutes. Okay, again, I apologize. I'm so hungry, I had to go grab a snack. And by the way, that was number 53, not 55. I mean, not 51, so we're now doing 55. All right, things are gonna start getting a little bit bumpy here. All right, we have f of x is x squared minus 9 over x plus 3. And then x squared minus 9 over x minus 3. This is what happens if x is less than 0, and this is what happens if x is greater than 0. All right, so here's the problem with this one. This one is not as easy to graph as the other ones have been. In fact, I would not want to sit here and try and graph that and do all that work. So instead what we're going to do is we're going to try and evaluate these limits as x approaches, what do they want us to approach? -3 and +3? Or, sorry, they want us to approach -3. Okay, yeah, let me just go through this. Without a picture, if we're going to try and say limit x approaches -3 of this function, of f of x, then what we need to do is we need to see what happens with direct substitution. If we try and plug -3 into this function, first of all, will we be here or will we be here? Well, if we're plugging in -3 into this function, we've got to be up here because -3 is less than 0, right? -3 is not greater than 0. So for this limit, we're focusing all of our attention into this one right here. And notice that when I try and plug -3 in, I get what on top? -3 squared. Get -3 squared minus 9 over -3 plus 3. So when we do this, on the top we get 9 minus 9 over -3 plus 3 is 0, so we get 0 over 0. And that is a problem because it appears that we are having an issue of this weird 0 over 0 thing. And so what we will say for this is that this does not exist. Hold on a second. I want to make sure I'm... Oh, sorry. Nope. I was looking at the wrong problem. I was looking at the one below it. Oops. Forget that does not exist. What we need to realize at this point is that if we get 0 over 0, this is the big problem. This is the reason why we're doing this, all right? Is to this business calculus. This is the calculus part, the part that requires some thinking. We're getting 0 over 0, which is a problem, but when we get 0 over 0, we cannot determine what the limit is yet. We have to see if there's any work we can do. So let's go back and let's just kind of leave this as a question. Okay, this tells us it's bad, all right, and we need to do some sort of algebra. So let's take a look at this up here. This expression up here can be rewritten. Because the top is a difference of squares, it can be rewritten as x plus 3 times x minus 3. And then on the bottom, we just have x plus 3. And notice that these factors cancel, and all we're left with is x minus 3. So as long as we're not trying to plug in -3, so as long as we're not plugging in -3, which would give us, if you plug in -3 here, -3, you get 0 over 0. But as long as we're not plugging in -3, then this should turn out to be this. And the limit allows us to get close to -3 without actually plugging it in. So what would happen to this expression, scrap this, what would happen to this expression if we plug -3 into it? We would actually get -3 minus 3, which is just the numerical value of -6. So this function should be approaching -6 as we approach -3. Now this is the first one I've done that's like this, so let's look at the next limit and see if we can't work through it again and see if it becomes a little more clear. So what is the limit as x approaches positive 3 of this function. Okay, so when we approach positive 3, we are now working in this function because 3 is bigger than 0. So we're going to plug 3 in here. Let me just do this mentally. 3 squared is 9, minus 9 is 0. 3 minus 3 is 0. So we are getting 0 over 0 there, which is a bad situation. Okay, we don't like this. But is there some algebra we can do on this to make that better? So again, it factors difference of squares on top. And on the bottom we have x minus 3. These cancel. And all we're left with is x plus 3. So what would happen here if we replace this x with 3? We would get 3 plus 3, which is positive 6. So that would be our limit. So whenever we're getting, I guess if I back up and kind of go through this again with you. When we're trying to do our direct substitution, if we get 0 over 0, which we did in both these cases, then you want to see if there's any algebra you can do to get better expressions that don't give you the 0 over 0. And that's what we were able to do here. And that gave us two answers, negative 6 and positive 6. Now, let's see if there's another thing here. Oh, you know what? This was part A and this was part C. I skipped part B. Part B was the limit as x approaches 0. Limit as x approaches 0. All right, this one's a little bit tricky. I'm kind of glad I'm doing this one now. So if I'm approaching 0, then I can't really do direct substitution because neither one of these have an equal sign. So if I'm trying to plug 0 in identically, I can't do it here and I can't do it here. However, the limit says we have to come in from the left and from the right. So if you imagine on a number line, we're coming in from the left and the right. If I come in from the left, then I'm actually going to be looking at that function because to the left of 0 means your x is smaller than 0. If I come in from the right, I'm going to be using this function. So what would happen if I replace x with 0? Okay, so I'm going to look at the left limit. If we come into 0 from the left, we're going to be right here in this function, x squared minus 9 over x plus 3. And what would happen if you did direct substitution of 0 into this? You would get negative 9 on top, and you would get 3 on the bottom, and you would get negative 3. Okay? We're not done, because that's only what's happening from the left. From the right, we have to be in this function. So it's x squared minus 9 over x minus 3. And let's go ahead and do a direct substitution of 0 in here, and we get negative 9 on top, and we get negative 3 on the bottom, and that's positive 3. So notice that the limit from the left required us to be on that function, which gave us negative 3. The limit from the right required us to be on this function, and that gave us positive 3. Since these two things don't match, then if you're asked what's the limit as x approaches 0 of this function, you're going to have to say does not exist because they don't match up. All right, that's it. Let's move on. 59. F of x equals x minus 2 over x squared minus 2x. And we're asked for the limit as x approaches 0, 2, and 4. All right, so what we'll do, thank goodness this is not a piecewise function. It's just a single function. We don't have to worry about breaking it up into different pieces right now. But let's figure out what's happening as x goes to 0. So we're going to do direct substitution. When we do direct substitution, 0 on the top gives us negative 2, and 0 on the bottom gives us 0. Okay, so 0 minus 2 is negative 2. 0 squared minus 2 times 0, that's 0. So we get negative 2 over 0. And anytime we get division by 0 like this is going to be does not exist. All right, this limit does not exist. Now let's try and plug in 2. So what happens if we plug in 2? Direct substitution. 2 minus 2 on top is 0. And then 2 squared is 4. Minus 2 times 2 is 4. So we're getting 4 minus 4, that's 0 on the bottom. Okay, we've got finally the bad situation here. So what we need to see, is there anything we could have done algebraically to make this different so that it's cleaner? And notice on what you can do is on the bottom is you can factor an x out. And if you factor an x out of the bottom, you get this. These two cancel, and you just get 1 on top and x on the bottom. Now we can get around this 0 over 0 by just using this function and plugging 0 into it. So if we plug 0 into this, I mean not 0, 2 into this, we get 1/2. And so the limit is 1/2. Now let's try and plug in 4. If we plug in 4 on the top, 4 minus 2 is 2. And then 4 squared is 16 minus 2 times 4. So 2 times 4 is 8. So you get 16 minus 8, that's 8. You get 2 eighths, which is 1/4. Notice we didn't have any problems. No division by 0, no 0 over 0. So that's the limit. There's no work to be done. So let's just kind of recap the different scenarios we ran into with this function. If we got a number, right, other than 0, if we got a number over 0, the limit doesn't exist. When we had 0 over 0, we have to do some algebra to make it work out. If we get just a number over a number without any division by 0 or anything, then the answer is just that number. All right, let's look at 61. It's a long video. F of x is x squared minus x minus 6 over x plus 2. We're going to be looking at the limit as x approaches 2 of this function. We're going to take the limit as x approaches 0 of this function. And finally, we're going to take the limit as x approaches 3 of this function. All right, let's start with 2. What happens when we plug 2 in here? When we plug in 2, we get 4 minus 2 minus 6. Right? 2 goes in here, 4 minus 2 minus 6 over the bottom 2, was it plus or minus down there? It was plus. Oh, crap. They wanted -2. Sorry, -2. I'm having trouble seeing the negatives in this book. They're so small. Okay, got to do this over. Okay, -2 squared is still 4. But minus 2 is plus 2. And then we have minus 6. And on the bottom, -2 plus 2 is 0. And notice we get 0 over 0 here. Okay, if we get 0 over 0, that means we need to try and do some algebra. So let's go back up to this and see what we could have done. And what we would notice is that's a trinomial, and that factors. It actually factors to be x plus 2 times x minus 3. Now I would trust that you could do that. And then the bottom is x plus 2. And these two factors cancel, and we're left with x minus 3. So to get around this 0 over 0, what we do is we algebraically simplify it first, and now plug in -2, we get -2 minus 3, which is -5. So our limit is -5. Good. Now let's plug in 0. See what happens, direct substitution. 0 up top gives us -6. 0 on the bottom gives us 2. And that's just -3. And there's no problems there. No division by 0, we're done. Okay, now let's do 3. What happens if we plug in 3? Well, on the top, and notice I'm not plugging it in here. Okay, I'm plugging it in here. If we plug in 3 on top, then we get, let's see, 9 minus 3 minus 6. And if we plug in 3 on the bottom, we get 3 plus 2, which is 5. So on the top, notice that we get 0. And on the bottom, notice we get 5. And 0 over 5 is just a number. That's just 0, right? So our answer is just 0. Now, if it would have been flipped over, we would have 5 over 0, then we would have said does not exist. Okay, now let's look at number 63. Number 63, we have f of x equals the quantity x plus 2 squared over x squared minus 4. And we want to take the limit x goes to -2, 0, and +2. X goes to -2, x goes to 0, and finally x goes to +2. All right, let's try -2. If I plug in -2 right here, I get -2 plus 2, that's 0. 0 squared is 0, so I'm getting 0 on top. -2 squared is 4. 4 minus 4 is 0, so I'm getting 0 over 0. That's telling me there's something bad happening here. So I've got to do some algebra. So algebraically up here, remember that top really just means this. And the denominator is the difference of squares. And one of the factors of x plus 2 cancel, and you're left with x plus 2 over x minus 2. So algebraically, it simplifies to this. Now try and plug -2 into this. And we're only doing this because we got 0 over 0. So we plug in -2. On the top, -2 plus 2, we get 0. And on the bottom, -2 minus 2 gives us -4. 0 over -4 is 0. So our limit is 0. All right, now let's plug in 0. So I plug in 0 right there. I'm going to get 2 squared, which is 4. And on the bottom, if I plug in 0 here, I'm just going to get -4, so -4. That's just -1, no problems. No division by 0, no 0 over 0, we're happy. Now let's plug in 2. Plug in 2 here, 2 plus 2 is 4. 4 squared is 16, the top is 16. The bottom, however, is going to be 2 squared, which is 4 minus 4, it's 0. We get 0 on the bottom. And this was that bad case. If we get a number on top, we get 0 on the bottom. Not 0 over 0, but a number over 0 like this, then our limit does not exist. Okay, 63 is done. Last one, 65. My battery's okay here? Yep, okay. F of x equals 2x squared minus 3x minus 2 over x squared plus x minus 6. I'm looking at the limit as x goes to 2, 0, and 1. All right, let's see what happens when x goes to 2. All right, that's going to be a little messy. 2 squared is 4. 4 times 2 is 8. Minus 3 times 2 is 6. Minus 2. All over 2 squared is 4. Plus 2 minus 6. So we're getting 0 over 0 here. And that's bad. So we need to try and do some factoring here. Up top, let's see if we can't factor that numerator and the denominator, since they're both trinomials. Now, the denominator might go pretty easy. Let's see here. The denominator's actually a little bit messy, but plus 3 and minus 2 work? You can check that for yourself. The top is going to be 2x and then x and then 2 here should be minus 2 and plus 1 here. So let's just double check that. We get 2x squared minus 4x plus x, which would be minus 3x, and then minus 2. So yes, that's it. And that's a great thing because these cancel. And all you're left with is 2x plus 1 over x plus 3. So I said a few times, I'm sure in class, you've got to be able to factor. Well, can't do this problem if you can't factor. All right, so now since I had 0 over 0, I went and did some algebra. Now I kind of come back here and I plug 2 into this expression. So 2 times 2 is 4, plus 1 is 5. And then 2 plus 3 is 5. So we have 5 over 5, which is 1. So our limit is 1. As we approach 2, the limit is 1. Now what happens when we plug in 0 into this function? So we get 0 here, it's dead. We just had negative 2. And then we plug in 0 here, we get negative 6. And that's just positive 1/3. No problems at all. Now let's plug in 1. So what happens if I plug 1 in here? I get 2 minus 3 minus 2. 2 minus 3 minus 2. And on the bottom, I get, plugging in 1, I get 1 plus 1 minus 6. 1 plus 1 minus 6. So you're getting on the top negative 3 over 2 minus 4. So positive 3/4. Okay, that should be it. I'm just going to double check that because I went through that really quick. 499. You can double check the arithmetic there, make sure I got all my numbers right. 499, number 63, 3/4, yeah, 1/3 and 1. Okay, that does it for that section. That was a lot of work.